Good afternoon. Today I'm working on geomorphology. I'm going to use the geograph paper 1 for November 2024. I'm going to go through geomorphology. That's the topic that I'm going to explore. So I'll be doing question number 2. Question number 2. I hope you can see it clearly. Question number 2. This is my question number 2. Match the statements in column 1 with the options in column B on drainage basins and write only Y and Z next to the question numbers. So when it comes to drainage basin in South Africa, the most important thing that you have to know or remember is you can have a question that asks you to define. You can have a question that asks you to identify the different, okay, these are the landforms. Of course, you can see there's a tributary. Okay, you can be asked you to identify, let's say you have a diagram like this, you can be asked you to identify the drainage basin in South Africa. Of course, what is the source of the river? Usually that's where the river starts. Watershed, highline area, separating two drainage basin. A drainage basin being the area drained by the river in these tributaries, confluence where two rivers meet or two streams meet, okay, mouth where the river ends. So you can have a question that asks you to identify. You can have a diagram like this, maybe out of 8 or out of 7, that asks you to identify the drainage basin, the tributary, the watershed. It can also be the interflow. So these are the type of questions that you'll have. Or you can have a situation whereby you are asked to define. Like, for example, I've got something here. Like you can be asked to define the following concepts. What is a drainage basin? What is a confluence? What is an interflow? What is base flow? What is watershed? You can be asked to define. But let's deal with what we have at the moment. Okay? So this is a match question where you've got the descriptions in column A, then you've got the option to choose from in column B. So the question reads, an area drained by a river and its tributaries. So that is your what? That is your drainage basin, which means your answer here will be what? Will be Z. Then it promotes a rapid rise in water table. What is water table? I think you need also to have an understanding of what a water table is. When you talk about the water, you talk the upper level of underground water, groundwater. That is your water table. Or the level of water underground. That is your water table. And when it comes to the water table also, let me just add something. When it comes to the water table as well, it rises during the rain season, and when it's rain season it goes down. Okay, which means during the rain season our water table is high, and during the dry season when we do not receive rainfall, then our water table goes down. So the question reads, promotes a rapid rise in water table, which means if we check or if you compare gentle slope, what does it do? It allows the water to settle, which means where you have a gentle slope, there's likely to be more infiltration taking place. But when it's steep, it means now the water, okay, the steepness, it encourages more surface runoff. So it means it's not going to add to the rise in the water table, because steepness, it increases more surface runoff. There is no infiltration that will take place. Water, as soon as we receive rain, then the water will start flowing. There is more surface runoff. It does not encourage infiltration, but gentle gradient, which means it's flat. If it's flat, water is allowed to settle, then obviously it's going to give rise. There's going to be more infiltration, which raises the water table. So our answer there is Y. Then the next one, the upper level of underground water, that 2.1.3, that is your water table. Remember, we have said that the water table during the rain season, what does it do? It goes up. Why? Because we are receiving rain during that time. Okay, water table goes up during the rain season, and during the dry season, when we do not receive rainfall, it goes down. Okay. Then seepage of water into the ground, that is your 2.1.4. 2.1.4, that is your infiltration, okay, that is a seepage of water into the ground, okay. Then causes reduction of surface runoff. So we are saying now, when you from the two that are given, that is impermeable rocks and dense vegetation, which reduces, okay, surface runoff. Okay, so we are going to look at the two and see which one reduces surface runoff. Okay, all right. So we are saying now where there is impermeable rocks, which means water cannot go underground. It doesn't allow water to infiltrate. It doesn't allow the water to percolate if it's impermeable surfaces. So it means we are likely to have more surface runoff where we have got impermeable rocks. But where we have got permeable rocks, we are likely to have more infiltration taking place. So dense vegetation, what does it do? If it rains, it means water, okay, water is allowed to settle, okay, then there it encourages more infiltration. So what it does is it reduces what? Surface runoff. When you have got dense vegetation, you'll see when the water, when it's raining, of course, the impact that it will have before it reaches the ground is going to be less. So as a result, it results in more infiltration where there's dense vegetation as compared where there is impermeable. Here there's bound to be more surface runoff, but where we have got dense vegetation, it's likely to result in more infiltration taking place. It's more likely to result in more infiltration taking place. You can take an example where we don't have any vegetation at all, which means some of the pore spaces on the soil are closed up. So this will encourage more surface runoff where we have got we don't have vegetation at all. Why? Because the impact that the raindrops will have on the earth's surface is going to result in the closure of pore surfaces, pore spaces on the soil, then which result in more surface runoff. But when it's dense vegetation, it actually causes a reduction in surface runoff. So it means your answer there is Z. Then the confluence is located at YZ. A confluence, by definition, we are talking about is where two rivers or streams meet. So this is an example of a confluence here. This is an example of a confluence. You can see there's a tributary. This is the main river. Where they meet, that's what we call a confluence. Okay? So if you check the two diagrams, you'll find that your answer there is Z. This is a confluence where these two rivers are meeting, or two streams are meeting. So this at Z is your confluence. Then the high-lying area separating two tributaries on the same river system. There are two concepts here. There is what you call an interflow and what you call a watershed. You can see here we have got two river systems that are here. So this is your watershed, high-lying area that separate two drainage basin or two river system. This is another one, and on the other side this is another one. So this one becomes your watershed. But if you have got a high-lying area that is separating tributaries within the same drainage basin, this becomes your interflow. This becomes your interflow. So your interflow is within the same drainage basin or river system. High-lying area separating two tributaries within the same river system or within the same drainage basin, that is your interflow. So here is an interflow. There is your watershed, two drainage basin, two river system, river A and river B, watershed. Then here is within the same river system, tributary, that's your interflow. So your answer there is Z. That's your answer. Okay, let's move on to the next one. We are moving on now to question 2.2. It reads, various options are provided as possible answers. Various options are provided as possible answers to the following questions on fluvial processes. Okay, and learn from features. Choose the answer and write only the letter A to D next to the question numbers 2.2.1 to 2.2.8 in the answer book. Okay, so if you look at this now, is responsible for the shape of the river valley. You can see, when you look at this, you can see that it's V-shaped. It's V-shaped. So what happens? Okay, let me just try to talk about what happens within the longitudinal profile of the river. Remember, we have got the upper course, we have got the middle course, then we have got the lower course. This is the middle course, this is the what? The upper course. In the upper course, what happens? The river is more erosive. As a result, there is more vertical erosion that takes place. That results in a V-shaped valley. Okay, same applies here when it goes to the middle course. You remember, there's more lateral erosion that is taking place, which means the valley becomes U-shaped. Same applies here. The river has lost most of its energy. There's more deposition taking place. It's wide, but it's also U-shaped. So what is responsible here is your vertical erosion. You can see with the V-shaped, it's cutting deep. That's vertical erosion, which means your answer there is D. When you talk about lateral erosion, we are talking about the erosion that increases the width of the river. from side to side, erode from bank to bank. That is your lateral erosion. Okay. What vertical erosion does is it increases the depth of the river. It deepens the river. It increases the depth of the river. That's what vertical erosion. So that's D. Weathering simply is just a breaking down of rocks into smaller pieces. When you talk about weathering, you're talking about this physical weathering, there's chemical weathering, there's also biological weathering. I'm not going to give much information as far as weathering is concerned, but basically I just wanted you to have a better understanding. Deposition, obviously, this is what happens mostly in the lower course when the river has lost most of its energy. It's also gentle at the lower course. That's why there's more deposition, which means the sediments that has been carried along the profile of the river are now being deposited because the river has lost most of its energy. That's what it's all about. Then forms at the base of a waterfall, 2.2.2. At the base of the waterfall, that is your plunge pool. Remember, your waterfall is more like this. This is resistant rock, less resistant rock beneath it, okay? So the water is flowing. That is your plunge pool. That's what we are talking about. It forms at the base of the waterfall. This is your waterfall, resistant rock. It erodes, obviously, is cutting back. Obviously, this overhang at some point, it can fall into the plunge pool, but this is your plunge pool, which means your answer there is what? Is a plunge pool, which is D. Then the fluvial landform feature depicted in the sketch is A. Remember, if you look at this, you can see the fluvial landform feature depicted on the sketch is A. I want to talk about the, what do you call it, the river discharge. Of course, this gives you more like a turbulent flow. Obviously, what will be your answer there, 2.2.3? That is your rapid, because you've got the resistant rock that are inclined along the riverbed. You can see when it's flowing now, it's sort of a turbulent flow. So your answer there is a what? Is a rapid. That is a rapid. That's what is your correct answer, 2.2.3. Then let's move on to the next one. 2.2.4, the flat low-lying area along the banks of the river in the lower course. All right, this is 2.2.4, 2.2.4. All right, the answer is C. I want to explain so that you understand. Remember, I was talking about the courses of the river. Remember, we said that we have got like this, okay? This is the source of the river. This is the mouth, okay, where the river ends. So this is the upper course, this is the middle course, this is the lower course. So we are saying now the flat low-lying area along the banks of the river on the lower course of the river. Remember, when here there's more erosion taking place, which is vertical erosion. Here there's more lateral erosion. Here there's more deposition taking place. So on the side, which means the banks of the river from side to side, okay, what happens usually, especially when it's flood, what happens is some of the sediments or alluvium are deposited on the area that is from the river banks going on the side of the bank. So this is how we end up having what we call a flood plain. Obviously, the area that is surrounding the river, of course, when it is in flood, it carries with it the sediments, alluvial soils that are fertile. They are deposited on the plain that is close to the river banks. So over a long period of time, you might find that that land can be used for farming, agriculture, because it contains fertile soils. So we are saying now it's a feature, a fluvial feature that you find at the lower course. Low-lying area along the banks of the river in the lower course, that is your flood plain. And also when it comes to the features that you find within the different courses, just to add, in the upper course, there is more erosion taking place, which results in vertical erosion, which means we are likely to have a V-shaped valley. We are also likely to have a waterfall. We are also likely to have a rapid, because the river is more erosive. The river has got more power. The slope there is very steep, which means the water is flowing at a very high speed, which is very higher. It has got a higher velocity. So we have got the V-shaped valley, we have got the rapid, we have got the waterfall within the upper course. In the middle course now, there is more lateral erosion that is taking place, which means it's eroding from side to side. We are likely to have meanders. We are likely to have ox volley, which is a cut off, which is more like a meander scar from the meander. That is your ox volley. We can also have, you can have an ox volley, okay, there. Then in the lower course, what are we likely to have? We're likely to have a delta. We're likely to have a floodplain. Even the meander and the ox volley are also found within the lower course. So you need to know the fluvial features that you find in the upper, middle, and the lower course as well, and the reason why we have got those landforms. Remember, I've talked about the floodplain. The river has lost most of its energy. Now materials are being deposited You understand? Here there's more lateral erosion from side to side. Where we have got in the outer bank, there's more erosion taking place. In the inner bank, there's deposition that is taking place. This is how a meander forms, okay, and so on and so on. Okay, let's move on. The slope at X on the inner bank of the meander is referred to as, all right, at X here, this is where deposition is taking place. This is where deposition is taking place. And here, this is where erosion is taking place. This is the outer bank, is the undercut slope. This is the inner bank, is the slip-off slope. The slip-off slope where deposition is taking place. So it's undercut, slip-off, undercut, slip-off. Here there's more erosion taking place. Here there's more deposition that is taking place, okay. So the answer there is 2.2.5, that will be your D, your slip-off slope. Forms when the meander loop is cut off from the main river. So we are saying now, that is 2.2.6, this is your river. Remember, here erosion is taking place, erosion is taking place, erosion is taking place. So over time, you would find that this part will be cut off from the meander, okay, is when the meander loop is cut off from the main loop. This will become a meander scar, a meander loop, okay, is cut off. The river will follow direct, which means this part will have been eroded. There's two processes that are taking place. There's erosion that is taking place here. There's also deposition on the inner bank. So you'll have an oxbow lake, which means part of this will become what? An oxbow lake. So the answer there is C. The benefit of natural levee is, these are just raised banks. These are just raised banks. Remember, when the river is in flood, some sediments are deposited on the side of the river. These are the raised banks. These are what we refer to as levees. Okay, 2.2.7, which means your answer, it reduces flooding. You can see these are raised banks, which means when the water is here, okay, it reduces flooding, which means your answer there is B, 2.2.7. Then 2.2.8. Oh, we are moving. Deltas form at the river mouth when the following conditions occur. Remember when I was talking about the fluvial features that are found in the upper, middle, and lower course. So we have got a delta at the river mouth, which means where the river ends, which means at the lower course of the river. What could be the reason? Close to the sea or the lake. That's where we have got a delta. The reason there could be one, it has got a shallow seabed. Remember, shallow is gentle, okay, as well. Then what else could be the reason there? Number 4, small tidal range, which means now the river is not that erosive. You understand? So which means the sediments are allowed to settle, is flat, all those things. That's what we have in the lower course of the river or in the river mouth. So your answer there is what? Is D. Okay, moving on to the next one, that is number 2.3. Refer to the drainage patterns A and B and below. Okay, when it comes to drainage pattern, what is important, guys, there is a relationship between the drainage pattern and the topography, where you find the different drainage pattern. So what you need to know when it comes to drainage pattern, you need to be able to identify. How do you identify the different drainage patterns? The most common one are the dendritic. We have got the dendritic, we have got the trellis, we have got the radial or centrifugal, we have got the we also have what you call the centripetal, okay. We also have the parallel one, we also have the rectangular. So what I'm going to do is I'm just going to give you examples, okay. You have got here, you can see, you should be able to identify. That's what is important as far as the drainage patterns are concerned. You are supposed to be able to identify. So if I'm to identify 1, 2, 3, and 4, okay, the first one you can see is dendritic. How do you identify a dendritic pattern? It looks like the branches of a tree. Tributaries join the main river at acute angles. So this is your dendritic. You can see the tributaries are joining the main river at acute angles. It also looks like the branches of a tree. That is your dendritic drainage pattern. You can see them. Moving on to the next one, that will be your trellis. How do you identify it? It's strong drainage patterns. Main river is joining the short tributaries at angles, okay. The main streams are parallel to each other. The main streams, they are parallel to each other. Look at the tributaries, they're joining at right angles. That will be your trellis, okay. If it's a rectangular, obviously rectangular, the main river, it's bending at 90 degrees. Also the tributary, they join at 90 degrees, okay. That is the major difference between the two. So your rectangular now, it will be like this is the main stream, okay. This will be like the main stream, okay, you can have your tributaries joining as well, but this one, the main stream will be bending, okay, at right angles. Then also you have the tributaries joining at 90 degrees as well. So this is a trellis. This is the main river. This is the main river. They are parallel to each other. That's your trellis, okay. So trellis, strong drainage patterns, main rivers joined by the strong tributaries at right angles, 90 degrees. The main streams are parallel to each other. That is your trellis. But when it's a rectangular, you can see it bends at 90 degrees. That will be your rectangular. Okay. The next one you can see is coming from a dome, okay, a higher ground, okay, domal shape, okay. You can see here what we have is from the higher area, higher ground, flowing downwards from a higher central point, flowing outwards. So that becomes your centrifugal or your radial. Centrifugal or your radial is coming from a higher point, flowing downwards, okay. So how do we explain that? It's radial, it radiates from the higher central point, such as a mountain or a volcanic mountain. That's what it does. That is your radial now. That's where it actually develops, or that's where you find it normally. It forms in areas where domes or volcanoes, okay, is associated with massive igneous rocks, okay. Then the last one, that would be your centripetal. Centripetal is streams flow towards a central basin such as a marsh or lake. So it means it's flowing from this, where it's flowing towards is the lower ground. Okay, there's a central point, okay, you can see like a lake flowing from a highland towards the lake. That is your centripetal. Stream flow outwards, out towards the central basin such as a marsh or a lake. So that will become your dendritic, that is your trellis, that is your radial, that is your centripetal. Okay, these are the different, I just wanted to, for the sake of, just to explain so that at least you have an idea of what this is all about, okay. So from there you can see what we have. Identify the drainage pattern A. So this one, as you can see, this is a higher ground. It's like a dome shape, like I've been talking about just now. That central rivers flow away from a higher central point. This is higher, like a mountain dome shape flowing downward. So that is your radial. That is your radial drainage pattern. That is your radial drainage pattern. Okay. That is your centrifugal. Okay. Determine the stream order X in the drainage pattern. When it comes to the stream order, now you need also, or you have to understand the concept. Stream order, I'm going to use this to explain the concept. So this is how it starts. Where the river starts, okay, 1, 1. So 1, 1, which means they are of the same order. They give you a higher order. 1 plus 1, you've got 2. Okay. Then here what we have, 1 plus 1, stream order 2. Then we have got stream order 2 and stream order 2. It is the same number, 2, 2. It gives you stream order 3. This is lower order, okay, 1, okay. So 1, this is, okay, second order, okay. We have got this and this, okay. What we have is still 3. It's still 3, 1, 1, 2. 1, 1, 2. 2, 2, 3. 3, 3, we get 4. 1, 1, we get 2. Then you have got 2 and 4, you still have 2, which is 4. So that's how you do the stream order, 1, 1, 2. 1, 1, 2. This one is already 3. 1, 3. It remains 3. Okay. 1, 1, 2. 2, 4. Obviously, it's going to remain 4. So that's how you do your stream order. Let's go to the question. The question now, it reads, determine the stream order X in the drainage pattern. Okay. Is second. Why? Because this is 1. This is 1, 1. Then here, which means it's 2. 1, 1, it gives rise to 2. That is the second order. Okay. Then give a reason for the direction in which the streams flow in the drainage pattern A. In A, radius outwards from a high-lying central point. Okay. Remember I said that the river flows away from a high central point, such as a mountain or volcanic mountain. So its radius is flowing away from the high-lying central point. That's what is happening. Then 2.3.4, how does the joining of the tributaries to the main differ in drainage A and B? You can see 2.3.4, the tributaries join the main river. Okay, what is happening? The tributaries is joining the main river at what angle? You can see it at acute angles A, and at B is at right angles. this is radiating from high central point, but you can look at the angle at which they're joining, acute angle. This one is joining at right angles, okay, which means you have got the main river is parallel to each other. That means this one is a trellis. That's what it means. It's a trellis. Why? You can have, they are parallel to each other. The tributaries are joining the mainstream at right angles. Okay, right angles, this one is less than 90. That's why we say acute angles. 2.3.5, set two conditions associated with the underlying rock that contribute to the formation of trellis drainage pattern in B. Okay, 2.3.5 is alternating layers of hard and soft rock. You can see alternating layers of hard and soft rock. Folded rocks, you can also give that as an answer. Alternating layers of hard and soft rock, that's how, okay, where you find your trellis. 2.3.6, why are human activities limited in areas where drainage patterns A and B are found? Of course, alternating hard and soft rock, here we are saying that high central point, it radiates going downhill from mountain or a dome shape. So what could be the answer then? Land is steep. You can see this is a high central point, is flowing downwards. So land is steep, that's number one, is uneven. Number two is prone to soil erosion. It's prone to soil erosion. They're thin soils. Why? Because it's steep. Okay, that's another reason. Then infertile soils, that could be another reason. Risk of mass movements, high cost of developing land. So this could be some of the reasons. Land is steep or uneven, prone to soil erosion, infertile soils, high risk of mass movements, high cost of developing land. So these are some of the reasons that you can give. Obviously, please, when it comes to drainage patterns, know the different drainage patterns. You should also be able to identify the different drainage patterns. This is your dendritic, this is your trellis, this is your radial, this is your centripetal. When you talk about a rectangular, obviously, the main river is bending at 90 degrees. Of course, when you talk about the deranged, where is it normally found in those areas, glaciated areas, you should be able to identify and explain. What is important when it comes to drainage patterns, identify it, name it, describe the rock structure, and also give a description. Like, for example, if I'm to give a description of dendritic, I would say, number one, dendritic, what happens? Rock structure, where is it common? Rocks of uniform resistance to erosion, massive igneous rocks and horizontal sedimentary rocks. Okay, what is the description? Drainage patterns look like branches of a tree and tributaries join the main river at acute angles or less than 90 degrees. I would have explained the rock structure and also the description. Then the second one, trellis. Trellis, alternating layers of hard and soft rock. That is the rock structure. Where do you find it? Strong drainage patterns, main river is joined by short tributaries at right angles. That's the description. Then the next one, the radial. The next one, centrifugal rivers flow away from the high central point, such as a mountain or volcanic mountain. That will be the description. Where is it formed? It forms in areas where domes and volcanoes, okay, associated with massive igneous rocks. Then the last one, centripetal. Streams flow outwards the central basin, such as a marsh or a lake. And what will be the rock structure associated with massive igneous rock? So I have given the description in terms of rock structure. I have also identified them. I have also explained in terms of the rock structure. Okay, let's move on to the next. Okay. So the next thing now is refer to the sketch below of river rejuvenation. Sketch below of river rejuvenation. Okay, sketch below of river rejuvenation. So when we talk about river rejuvenation, what is it all about? Okay, we are now saying that this is when the river becomes more erosive and there's more vertical erosion that is taking place, which means there's an increase in energy. This is what makes the river more erosive when you talk about rejuvenation, giving more power. It becomes more erosive, there's increase in energy, it becomes more erosive and it starts to erode vertically. Okay, so those are the two things that you have to take note of. The river becomes more erosive, it has got more energy, then it starts eroding vertically. This is how you explain the concept of a river rejuvenation. The river is now more erosive, there's more vertical erosion taking place, it has increased in terms of its energy, the river energy. This is what actually would have taken place. So when you talk about river rejuvenation, the river has become more erosive, it has got more energy, it's eroding vertically. That's what it's all about. If you look at this diagram, of course, this is a feature that results as a result of river rejuvenation. You can see it's cutting deep. It can be valley in a valley, it's cutting deep, of course. Okay, we'll talk about more about that. Okay, so that's what happens when you talk about river rejuvenation. So again, when the river experiences an increase in energy and it starts to erode vertically, the river is now more erosive, then it starts to erode more vertically. That's what river rejuvenation is all about. Then the second one, identify the feature at A. The feature at A, you can see, we can say it's a nick point or a waterfall. You can see where there's a sudden change in gradient. You can see along the river, now it just starts to erode vertically. That's a nick point, or you can have a waterfall then. That's what feature A is. That's how the river has been rejuvenated. How does feature A indicate that the river rejuvenation is taking place? There's a change in gradient. You can see the way it is here. Now there's a sudden change in gradient. There's a drop in gradient. There's evidence of vertical erosion that is taking place. Water is now flowing fast, which means the river is now more erosive. There's the higher velocity in terms of the way in which the river is flowing. There's evidence of older and new river profiles. You can see from where it's coming from, and now this is a new river profile. You can see it has now eroded vertically. Now that's what it's all about. Those are the evidence that you can talk about. I've said that the change in gradient, evidence of vertical erosion, water is flowing faster, and evidence of old and new river profile, which means now the river has been energized. Now that's basically what we're talking about. Describe the change that river rejuvenation has made to the landscape at B. What changes have been made there? 2.4.4. It has formed a valley in a valley. This is already a valley, but because of vertical erosion, which means now the valley has been deepened. That's a valley in a valley. The deepening of a valley that already existed. There's a valley that was already there, but it has been further deepened because of vertical erosion, because the river has become more erosive. That's how you end up having a valley in a valley. That's basically what we're talking about. The river channel got deeper and steeper. Why? Because there's more vertical erosion that is taking place. That's how it became more deeper and steeper. Okay, then 2.5, 4.5, how do river terraces form? Okay, if you can check here, this is an example for a river terrace. You can see the step-like feature here. You can see up to where we are now. Okay, so how is it formed? I'll just give you an explanation. You can see what we have. The first thing is vertical erosion occurs on a flat plane, assuming that this is part of our flat plane. Vertical erosion occurs on a flat plane. Okay, when it occurs on a flat plane, what happens? A new river valley is formed, which means even from where it started, okay, assuming that it used to be here. So it means there is vertical erosion that is taking place on a flat plane, and when that erosion is taking place, which means a river valley is formed. Especially we are talking about a V-shaped river valley. That's what is happening as a result of vertical erosion taking place. This creates a step-like feature. These are the step-like features that you have here. Step-like features that you have on both sides of the valley. Of course, step-like feature happened known as terrace. The old floodplain is now the river terrace, which means this is now the river terrace, as you can see there. Okay, why are some river terraces not suitable for farming? 2.4.6, obviously it's far from water sources. You can see this is where water is. These are where the terraces are on the side of the river channel. Of course, it's far from the water sources. It's expensive to build infrastructure. River terraces can be very narrow, limited use of machinery. Obviously, when it comes to farming, we use machines. Decrease in soil fertility and thin soils, uneven slopes, rugged landscape, unstable soil mass movement. So these are some of the reasons as to why it's actually not suitable for farming. Of course, we need fertile and also flat land. So these are some of the things that we have in as far as where a river terrace is formed. So when it comes to river rejuvenation, there's something that I need to mention. What are some of the features that are formed as a result of river rejuvenation? We talk about your river capture, which is when more energetic rivers capture the headwaters of a less energetic river. So that's how river capture actually takes place. So it also is a result of river rejuvenation. That's how we end up having what we call a river capture. What is it that I'm talking about? Okay, when you talk about river capture, this is before the capture. This is before the capture, as you can see there. That is before the capture. We have got river A, you have got river B. Of course, this becomes your watershed. Where you've got this becomes your watershed. Okay, this is before the capture, this is after the capture. What had happened now, you can see now it's eroding back. Okay, backward erosion that is taking place, that is eroding back on the watershed, such that it end up capturing the headwaters of river 2. End up capturing the headwaters of river 2. Let's see what is happening. So it means now, if you look at this landform now, you can see now this becomes more your elbow of capture. This becomes, okay, your elbow of capture. This is your elbow of capture. This is a wind gap. This is a misfit river. Of course, obviously, it means this river over time, it will dry out because it does not have a supply of water. Okay, the river has been added to this river now, which means it becomes more erosive. It has now been rejuvenated because it has captured the headwaters of river 2. So it has now been rejuvenated. The water is flowing at a very high speed. It has got higher velocity. That's how it has been rejuvenated. Okay. So what is happening is, if you look now at river A, what will happen at river A now? River 1, increase in volume of water in the river, okay, increase in velocity of stream flow of water, increase in vertical erosion due to increased flow. That is at river 1 because river captures second place. Results in rejuvenation of the river, increase in carrying capacity. These are some of the things that happen inside meanders, which means the cutting deeper of meanders because of vertical erosion. A formation of nick point, increase in size of drainage basin. This is what happened because this river has captured the headwaters of river 2. So it has been rejuvenated. Okay. Let's move on to the next one. I was just trying to add some more information. So, okay, this one we are done. Let's move on to the next one. That is your 2.5. Extract, refer to the extract below on catchment and river management. I'm going to read. River catchments are under severe pressure in some parts of South Africa. The plentiful water they provide is mean that the fertile ground surrounding them is an ideal place for agricultural activities. They are areas of natural beauty and often support both plant and animal species. Unfortunately, humans have not always recognized the importance of river catchments. When toxins and heavy metals leach into the catchment areas, they can endanger the lives of flora and fauna. Agricultural runoff can carry chemicals into the river catchments, creating an imbalance in nutrient levels and the impacts of different species in different areas. Fortunately, we are now beginning to pay attention to the conservation of vital natural resources. So I just want us to highlight some of the things that I feel are important in as far as this extract is concerned. The first thing is the river catchments. Of course, you need to highlight it. They're under severe pressure in suffering. Of course, it means there's a problem. Under severe pressure, it means there's a problem that has been noted. Okay, the plentiful water, what do they provide? They provide water. Okay, this means that the fertile ground surrounding them is ideal place for agricultural activities, which means the fertile ground surrounding them is conducive for agricultural activities. They are areas of natural beauty and often support both plants and animals. Okay, the aesthetic nature of these, okay, that's what we refer to as natural beauty. These are some of the benefits, okay, what we should appreciate, the reason as to why we should conserve, we should take care of our catchment areas and river networks, okay. Unfortunately, humans have not always recognized the importance of rivers, which means already there is a human effect, okay, on the catchment areas, also on the reservoir, which is negative. That's why it starts with the word unfortunately. When toxins, this is the part of pollution that is taking place, and heavy metals, okay, leach into the catchment areas, they can endanger the lives of fauna and flora. Flora, it refers to the plants, and fauna to the animals, which means these toxins that we are releasing into these catchment areas, they actually result in the extinction of some of these species. That's basically what we're talking about. Agricultural runoff from chemicals, we are not talking about eutrophication now. The chemicals that are used on farming, they can find their ways into these catchment areas, which means they can also have a negative impact, creating an imbalance in the nutrient levels and impact the different species in the different ways. So you need to be able to identify or to highlight some of these most important things so that at least it helps you to answer the question. Okay, let's start with the definition 2.5.1. This is a concept which means you should know what river management is. It's 2 marks, okay? Monitoring, controlling, management of water resources in a drainage basin or catchment areas. So it has something to do with monitoring and control of water resources in a drainage basin or catchment area. That's what river management is all about. You are managing, you are monitoring, you are controlling the water resources in a drainage basin or catchment area. That's what river management is. Then number 2.5.2, name one human activity in the extract that has a negative impact. There is one human activity. Where is it coming from? The extract. What impact? Negative impact on the South Africa's natural catchment areas, 2.5.2. So we're saying it's agriculture. That's what is being talked about here. It's agriculture. That's then human activity that has negatively impacted the South African catchment areas. Okay, so that's what it's all about. You can see it's mentioned also in the extract. Toxins, heavy metals of catchment areas, agriculture runoff, carry chemicals into the river catchment area. So that's your agriculture. Then 2.5.3, how does the human activity answer in question 2.5.2? Okay, the human activity, of course, is agriculture. All right, how does it what? Negative impact on the healthy water quality of catchment area. Of course, you know there are chemicals that are and toxins that are being released, 2.5.3. So how is it? It causes eutrophication, those chemicals that are finding their way into the rivers, okay, causing eutrophication, reduction in oxygen levels, imbalance in nutrient levels in the river. I think it's there, imbalance in nutrient levels, okay, in the river, reduction in biodiversity, reduction in fauna and flora, that's another effect. Water pollution, increase in waterborne diseases, ecosystem or natural habitats are disrupted, water table will be lowered, increase in soil erosion. So those are some of the things that you can actually include. Okay, the human activity, agriculture, how is it affecting the environment? Okay, the water quality, I've already said it. Eutrophication, imbalance of nutrient levels in the river, reduction in biodiversity, reduction in fauna and flora, water pollution, increase in waterborne disease. These are some of the problems that are actually caused negative impacts, okay? Negatively impact on the water quality, okay, which means there's water pollution that is taking place. Then 2.5.4, in a paragraph of approximately 8 lines, suggest sustainable, okay, this is a paragraph question, all right? Suggest sustainable strategies the government can put in place to preserve river catchment areas. So we need to find out alternatives or strategies that are sustainable, okay, to preserve the river catchment areas. What is it that we are going to do? 2.5.4. There is a lot that we can do. Educational programs, awareness, actually. Educational programs, that's one thing that we can do. We are telling people so that they know the effects of pollution on these catchment areas. So educational programs, that's one thing that we can do. What else can we do? We can also, awareness programs, implement legislation, laws, conservation zones. We impose fines. We can improve wastewater and greywater treatment. We can create buffer zones. We can encourage afforestation. We can remove alien vegetation, which is foreign plants. They are not indigenous plants. That's basically what you're talking about. Like the water hyacinths. If you have been to Harties, you will know what I'm trying to talk about. We remove that water hyacinth. That's basically what you're talking about. Okay, proper sewage and water purification system. Maximize wastewater and greywater usage. We can frequent testing of water. We want to test the water quality. We can conserve the wetlands. We can recycle agriculture, domestic industrial waste, sustainable farming, encourage rainwater harvesting. Those are some of the things that we can do. Remember, you are supposed to give the point and the qualifier. You explain your point in full. This is a paragraph question. Okay, you're supposed to explain your point in full. Educational programs, awareness programs. So these are some of the things that you can actually do. Impose fines. Obviously, we are trying to make sure that we preserve the river catchment areas. So what I just want to say in conclusion is, when it comes to geomorphology, what is it that you should take note of? When it comes to geomorphology, you need to know the drainage basin in South Africa, which means I'm talking about the different concepts that you have done under the drainage basin, like your water table, like your catchment area, like your river source, river mouth, the interfluve, your what do you call it, your watershed. So you need to be able to define those concepts. That's one thing. Secondly, you can have a match question where you're supposed to match a statement with the concept. You should also be able to know the definition. This is something that you're supposed to know as well. Then the other thing, when it also comes to the drainage basin in South Africa, you should be able to identify them from a diagram. Like this is an example, identify from a diagram. This is a confluence where two tributaries meet, river mouth where the river ends, and so on and so on. Then when it comes now to the fluvial processes and landforms that are formed, Of course, I have talked about what we have in the upper course, what we have in the middle course, and also what we have in the lower course. Upper course, there's more vertical erosion because the river is more erosive, it's steep, okay? So we end up having the waterfalls, also end up having also what we call the rapids, okay? In terms of river discharge, we have got a turbulent flow in the upper course. You understand? But in the middle course, what we have now, the river now, in terms of its velocity, has been reduced a bit, but we still have vertical erosion taking place, but there's more lateral erosion taking place. As a result of that, there is we have got meanders, we have got Oxford Lake, we can also have a braided stream then lower course, we have got your delta, your floodplain, you of course also have a delta, your floodplain. These are some of the landforms that you have. So you need to know the landform that you have in each and every course of the river, the upper, middle, and the lower course. You also need to be able to know the longitudinal profile of a river, which means from the source to the mouth, the converse section, or we call it the cross section of a river, which means from bank to bank. Where do we have a V-shaped valley, and what are the reasons behind that? More vertical erosion. The river is more erosive. In the middle course, it's U-shaped. Why? Because now we have got more lateral erosion, which erodes from bank to bank. In the lower course, the river has lost most of its energy, which means it's more wider. So you need to know about all that as well. Then when it comes also to the meander, where is erosion taking place? Outer bank. Where is deposition taking place? The inner bank. So this is a cut-off slope, undercut slope. This is a slip-off slope. So you need to know the cross-section of a meander, which means if you are going to be asked to draw a cross-section of a meander, let me see if I can get my pencil, which means from what you are seeing, which means here is going to be shallow, where you have got X. Then on the inner bank is going to be like this, which means here there's deposition taking place. This will be more like a cross section. There's more deposition, there's more erosion here, then there's more deposition here. This becomes your inner bank, this becomes your outer bank. So you should be able to know your cross section of a meander as well. And Oxford Lake, of course, it's cut off from the meander. Meander scar, remnant of the meander. Of course, there is deposition and erosion that is taking place, okay? Then what else do you need to know? You need to know also the drainage pattern, the drainage patterns, identifying them, explaining the rock structure, as well as giving a description. That's what is very important. The most common ones are your dendritic, you've got your trellis, you've got your parallel, you've got your rectangular, you've got your centrifugal, and your centripetal. I think I've already shown this, okay? Like from this paper, you can see what you have. You've got your dendritic, you've got your trellis, you've got your centrifugal, you've got your centripetal. This is also known as a radial. Should be able to identify them and also explain how they are formed. Then you always have a question, okay, before I move to that, river rejuvenation. What is river rejuvenation? What are some of the landforms that are formed as a result of river rejuvenation? I've talked about the river capture, I've talked about the valley in a valley, we've talked about the river terraces for my explanations when I was going through the question paper, we have talked about the incised meanders, the nick points, some of the things that you find in as far as river rejuvenation is concerned. So you have to make sure that you know about all that. Then you always have a question about river or catchment, river management or catchment area. So this is where you're supposed to maximize, get more marks, okay? It's very easy. Just know the concept, what is river management, get the answer even from the extract, and so on and so on. So boys and girls, thank you. I think we have gone through the 2024 paper 1, geomorphology. This is what we did today. We covered only question 2, which covers geomorphology. I've done already the climate and weather, so I'll see after 2 days. I'll also try to go through the last year prelim, the 2024 prelim, geomorphology only. I think I'll do about 3 papers to make sure that you are ready for the paper 1 that you are going to write, I think in 2 weeks or in a week time. Thank you so much. Subscribe. Don't forget to subscribe to my YouTube channel. The link is on my TikTok bio. So please, you can subscribe to my YouTube channel. Please go through this in preparation for your paper 1. Thank you so much. Bye-bye.